Today we're going to work on section 110, solving equations by adding or subtracting. Let's start with solving equations by subtracting, and there are some terms and some things that we need to know. The first thing that we need to talk about is inverse operations. Inverse operations undo each other. We'll put that in quotes because it's not really a technical term, but it's a term that we use a lot of times in math to show how these inverse operations work. They undo each other, and we'll talk about them more in just a minute. Next, we have the subtraction property of equality. We're just adding to our list of properties that we've already discussed this quarter. This property says that if you subtract the same number from each side of an equation, the two sides remain equal. And we'll see specifically what that means here in just a minute when we start working some of these problems. The other thing or term we need to know is equivalent equations. And equivalent equations have the same solution. For example, x plus 4 equals 7 and x equals 3 are equivalent equations because when you solve them, they both have the same solution. They both have the solution 3. And we'll look at that more in just a minute. All right, let's take a look at some examples. X plus 4 equals 5. What we're going to do is we're going to use the inverse, as we discussed above, or the opposite, in order to undo these equations and get the solution. So the inverse or opposite of addition is subtraction. So in our equation, x plus 4 equals 5, we are adding 4. So in order to solve it, we're going to subtract 4 from both sides. And we do need to show our work on this on both sides of the equation in order to get these right. So x plus 4, we're going to subtract 4 from this side, and we're going to subtract 4 from this side of the equation. We know that 4 minus 4 is 0, so this is going to leave x on this side, and 5 minus 4 is 1. So the solution to this equation is x equals 1. We can check that by substituting what we know x is, in for x, so 1 plus 4 equals 5, 5 equals 5. So yes, we did get that correct. In number 2, we have x plus 5 equals 2. So to solve it, we're going to subtract 5 from both sides. Subtract 5 from both sides, so we'll take minus 5, minus 5. We know that 5 minus 5 is 0, so that leaves us x on this side. And 2 minus 5 is negative 3. If you're not sure about your integers just yet, find you some space and work that out so that you would have, we'll just show it over here, 2 minus 5 equals 2 plus negative 5. And we know that 2 plus negative 5 is negative 3. If you need to show work, go ahead and show it. And in our last example, number 3, we have y plus 4 equals negative 3. We're going to subtract 4 from both sides. In order to undo the addition. So y plus 4 minus 4, negative 3 minus 4. And we get y equals negative 3 minus 4 is negative 7. Once again, if you need to show your work, go ahead. And we can check all of these the same way. Here, y plus 4 equals negative 3. We know that y is negative 7. Negative 7 plus 4 equals negative 3, and it does in fact. Negative 7 plus 4 is negative 3, and so we know we got that correct. If we look down at the bottom, we're going to graph the solution of an equation. So to graph the solution of an equation, let's just look at number 1 above. We've got x plus 4 equals 5. And we said that the solution was x equals 1. So we're going to draw our number line. And then we're going to draw a dot on the solution, which is 1. Very simple. Okay, let's look at the next page of your notes. On the next page, we're going to talk about solving equations by adding. So the first thing we want to do is the addition property of equality. And the addition property of equality is very similar to that of subtraction, only this time it says that if you add the same number to each side of an equation, the two sides remain equal. So let's take a look at the examples. This time we've got where we are subtracting instead of adding. So we're going to talk first about our inverse or opposite. Of subtraction this time is addition. So we will use addition to undo the subtraction in these equations. Let's take a look at the examples. R minus 5 equals 10 means we're going to add 5 to both sides. So plus 5 plus 5. So we know that negative 5 and positive 5 equals 0, so we get R equals 15. You can check your work the same as you could on the addition ones. R minus 5 equals 10. R equals 15, so 15 minus 5 equals 10. 10 equals 10, so we know that we got it correct. Number 2, once again we're going to add 5 to both sides because we're subtracting 5 in the equation. So we add 5, and that gives us 13 equals R. And in example number 3, x minus 6 equals negative 2, so we're going to add 6 to both sides. We add 6 to both sides, we get x equals 4. If you need to show your work, negative 2 plus 6, you know that you have to subtract them. You have more positives, so it's positive. Down at the bottom, we're going to use equations to solve problems. So we know the word sum means plus. We know when it says a number, we're going to use a variable. I'm going to use x. You can use whichever variable you want. So the sum of a number and 9, we know we're going to add x plus 9. The word is means equals, and then equals negative 2. So is equals, just so you know. And then we're going to solve this equation. So we subtract 9 from both sides, and we get x equals negative 11. So you have to be careful. Once again, show your work for those if you need to. Negative 2 minus 9, same, opposite, opposite, equals negative 11. So show your work where you need to instead of making careless errors. All right, let's take a look at the last page of your notes for solving equations by addition and subtraction. And this one says, in the 2000 presidential election, Indiana had 12 electoral votes. That was 20 votes fewer than the number of electoral votes in Texas. Write and solve an equation to find the number of electoral votes in Texas. So let's figure out what we know. First of all, we know that Indiana had 12 electoral votes. We know that that was 20 votes fewer than the number of electoral votes in Texas. So let's write down what we know. Indiana equals 12 votes. And here's what we know about Texas. We don't know exactly what they had, but we know that we can call it X. And we know something else about Texas. We know that the number of votes in Indiana were 20 votes fewer than Texas. So X minus 20 equals 12. We'll add 20 to both sides to solve. X equals 32. So Texas had 32 votes. At this point, we're going to have you just take a few minutes and pause the video, work the practice problems. When you come back, I'll show you what the answers are. If you got them right, that's great. If you didn't, then you can take some time, rework them, and then ask questions tomorrow in class if you were unable to get the answers. Okay, you should have worked the problems at this point, and so the answer to number 1 is going to be y equals -5. The answer to number 2 is going to be a equals -14. And the answer to number 3 will be t equals -4. Number 4, the sum of -5 and a number is -15. Write and solve an equation. -5 plus x equals -15. This one's a little bit harder because you have a -5. We're going to add 5 to both sides. We'll have to talk about this one a little bit tomorrow. And we get x equals -10. If you got those correct, that's great. If not, take a few minutes to look back and see if you can figure out what you did wrong. And if you can't, then we'll discuss it tomorrow in class.